Welcome to the second part of the points primer video series. In this case, I've been borrowing data material from one of my colleagues, Cecilia. It's on sort of commuting distances, so we've got origin and destination for commuters in the greater Lusaka area. So what we see here is respondents where they work, in fact, not where they live but where they work, and a few roads just depicting the area. If we right click on the workers file and look for the attribute, we can see we've got workplace X and Y, we've got start X and Y, which are equivalent to the central point of each of the neighborhoods. And the neighborhoods are defined as the Garden, Garden 2, Linda 2, Bauleni, and so forth. So there's a few sort of different kinds of neighborhoods in the area that are origins, and then many different destinations where where they can commute. We also got information about the gender and livelihood of the individuals, and as you can see, quite a few. We got 855 unique trajectories. This is a very rich and very good data set. So first of all, we just created something called Lusaka workers. And the simple thing we want to do is just to find out if the distribution of points are clustered or not. And a very typical way of doing it, we're not looking, by the way, into the values themselves, but rather into the composition of points, because each point is one individual workplace. We want to see if the clustering of workplaces is there. So the best way of doing this is to go for the average nearest neighbor. I search for that function. And it didn't show up, probably because I'm doing it in, there you go, in English. If I go for average nearest neighbor and I choose Lusaka workers, and I can choose Euclidean distance or Manhattan distance, it's up to you really what you want to do. I don't have any area that I want to look into, but I can also generate a report. So if I click that one, you will have something of a web page that we can open up and find out. So if I click this and I move this away, as you can see, it continues to think, and then eventually it's ready. I'm going to go to the results section. I go to the average nearest neighbor. Let me see if I can expand that for us, and we can see we've got a negative value of the z-score for -50, and the probability, the expected value is quite different. So if we look for the reported file, let me see if I can get that for us in a more sensible way. This is what it looks like if I'm doing it just a little bit. We could see that it's clearly very clustered. We see the z-score is negative and the p-value is 000, which means that this is something that ain't random. It's very likely something that is got to do with the distribution of jobs in the Lusaka area. If we go back to the video, we can go do so many other kinds of tests with this. Another kinds of thing we want to find out is what's the central feature of all the workplaces in the area. So I go for the central feature, but rather this time than going into the function itself, I can in fact go to the toolbox, which is in the spatial statistics tool. We got a few very interesting ones that I want to analyze as we go. So central feature, if I move that away, we click it, we can see by the description that it looks for all these ones and it finds the location which is most central. So very simple, Lusaka workers, we just simply sort of accept all the other settings. Again, we can do different kinds of distances and so forth, but we're not going to do any weights. So it thinks for a little while. This is a function that actually can take quite a long time if we're doing it on a very large data set when it comes to central features. You can see the larger blue dot in the central parts. That will be the centralmost feature of all these features. So we've got one location that represents them all. But if we, of course, using the same kind of logic, rather than central, which is the feature itself, we can create a mean center which calculates the mean location rather than the centralmost location. Again, if I do this, it will continue and it will probably render a point which is very similar. No, not really. It's a little bit south. And the median, of course, with the same kind of logic, we input the Lusaka worker, we accept all the other ones, even though we know there is a possibility to do so. We can find the median, and the median of course will accept something that already exists, which in this case is very close to the central one. So 3 different ways of locating the center of the working environment in all of these cases. One of the beautiful things about this data set is that we've got the information on what different kinds of groups. So we could, for instance, look for the most centralmost point when it comes to gender, or what kind of livelihood they would have. So later on in this data set, we're going to return to the fact that you could select specific conditions and qualities in the data set that you then can change and alter the results. One way we could look for these kinds of things is the distribution of the points, in what sort of the center and the distribution and the angle of how the jobs are located. The function that we quite usually use is the directional distribution, or the standard deviational ellipse. The standard deviational ellipse is interesting in that, as you can see here, it's got a few points and it looks for the area that contains one standard deviation around the mean position for where the points are located. You could in fact choose 2 or 3 standard deviation, then sort of expanding to having all in when you have 3 standard deviations literally every point in the data set. So we'll keep it to 1. But if I do this and I select Lusaka workers and I let these ones be default and I choose 1 standard deviation and I click OK, it will use all the points, but it will try to, around a specific area, find the area in which sort of literally then 2/3 potentially of the population is located. We can see this by going, let me see if I go this zoom to layer, we've got a few points outside that I didn't include when we were running the models, because it would sort of make it difficult for us to see what's going on in the central parts of the city. So if we again return to the previous view, we could see that we've got concentration. Again, this is interesting. If we do the select by attributes and we choose the Lusaka workers, and in this case we go for gender, we get the unique ones, and in this case we've got 2 different spellings of male, which is perhaps a little bit unfortunate, but if we go for instead the female, so we select all the female ones, we apply to this, and let us redo the directional distributions again. We just have to change the name. And as we could see, if I run it again, is that this one is slightly different. And to make sure that we've got something else, I'll go for a greyish color for the female ring. As you can see, they're pretty much the same all compared to women, but again, this way you can select and do a new standard deviational ellipse surrounding any population you've got in your selective window. If we disregard the fact, this is sort of just conditions that we've got dealing with the points themselves. If we take them away and return to the points we've got, let me see if I can minimize these values that I've got on my left hand side there, and I'll go for select, clear selected features. And instead now I'm going to use the material to create lines from the points. We could of course create something of, let me see if we got it here, search function is there, points to line. If I do that, points to line, we will create from the Lusaka worker a line that connect all these kinds of points. The thing is, it really doesn't make any good sense, because it will try to connect the first, second, third into a spaghetti mayhem that makes, well, no one happy really. This is just a way of connecting all these points. If you got a logical order, so say that the first ID, the first case, the second, third and fourth and so forth are consistent to be of a root, this is a sensible way of dealing with things. But in this case, when they represent various kinds of IDs, it doesn't really make any sense at all. So I'm going to take that away. I'm rather going to return to the fact that we've got the origin, start, and the destination of each of these individuals, which makes the dataset so much more interesting. So the better function to use is in fact the function xy to line. So xy to line, and I get an opportunity for me to fill in what kind of table I'm going to use. I'm going to use the Lusaka worker. I'm accepting all the names. The start field X would be start X, start Y, and X would be the workplace, and the workplace Y would be this one. I'm going to go for the geodesic, and the ID in this case I'm going to do somewhat different. I'm going to use residentia, because in the next step we're going to look for generalization of line patterns based on the on the location of the homes. We're going to accept the spatial reference, and I'm going to click OK. We wait a little bit, and this is what we get. It's a much more interesting data set where we could see, if we zoom in, let me see here perhaps, we could see that from the designated origin, which are all located in one area, you got the lines connecting it to the workplace. In this way we have a sense of opportunity and possibility to actually look for the distances being commuted from the home locations to the residential locations. So for each unique individual we connect the flow between I and J, talking geo-computationally here. One way of making it even more attractive in terms of how we could see and generalize things is the function called linear directional mean. See, if I go for the linear directional mean, see if I've got it already being conducted. No, it hasn't. So I have to do, let me see, I think that might actually be here. Mapping clusters. No, it's not. So I have to go just for the search function for that one. Let me see if we got something there. The linear directional mean is interesting because it collects the directories, the origins to destination lines. And in this case it can be used to create a generalized picture of the angle, the average position, the mean position, and the length of the commute. So we can try to generalize and make statistics from any location, trying to find out how do they behave in location X. What we had was the Lusaka workers XY to line, and since we had the residentia as being the ID, I know that each of these locations represent a specific place. So we've got different locations in Lusaka. Each of them have been named. I think there are literally something like 9 or 10 different residential areas. Using this technique, we can create one line that generalizes all the flow that comes from that specific point. And it could, of course, be used in statistics, but also to illustrate the flow of individuals. So I click OK and close this. And we got a few interesting lines there. See if I come, let me see if I can take out the lines or keep those in perhaps and just take away the individuals. We can see we got 3 different neighborhoods. On the top level up here we got 3 lines that generalizes it, and we got another one there. We got 1, 2, 3, 4, 5 in the southern parts. If I would to do sort of a very short description of what we can see, I would say that the 2 suburbs being located closer to the urban core area has got shorter and more core focused commuting distances, because they do represent, of course, home to commuting workplaces. For the ones being represented by the southernmost part here, they are the generalized patterns of the areas being a little bit further away from the central parts of Lusaka. And as we can see, the lines are longer, representing longer commutes, and the directions is less connected to the central parts of the city. So these individuals probably got another kind of work environment. They don't work in businesses in the central parts of the city. They might be working like farmers or in any other kind of a function. This is just one way of depicting what we can do with points, making them into lines and trying to find out the way these are sort of connected to each other and so forth. Don't forget that the selection tool, where you can select specific feature for specific groups and combinations of groups, could be extremely useful for understanding how the clustering and the directions of various kinds of individuals look. That will be all for the part 2 of the point primer. Thank you.